So let's start the lesson. So today we are going to talk about one of the enzymes in our body. It is catalase. The catalase. It will dissociate hydrogen peroxide. Okay, just write it down here first. If you idea what we're going to talk about today, it's H2O2. So before we talk about this enzyme, let's do a small revision on enzyme first. So can you just fill in the blanks here and draw the graph using the instructions right here, and also fill in these two blanks. You should know what to be filled in here. Okay, so let's go through this part together. What is enzyme? It is a catalyst, right? So what is a catalyst? Do you remember that? Yes, a catalyst is a substance to increase the rate of reaction. For enzyme, it is also a biological catalyst to increase the rate of metabolism, right? If without enzyme, the metabolism will need several days, and there is a lot of toxins stay in our body. So enzyme is really important to us. Okay. By lowering what? This is a key function of enzyme. Lowering the activation energy. Yes, that is the key function of enzyme. Okay, so the next part we need to draw the graph here. So draw a blue line to indicate the effect with enzyme. So just what I've mentioned here, enzyme is to lowering the activation energy. So just draw a line that with lower peaks of the original graph. Okay, you should have a graph like that also. Let it draw it better. Okay, so just there is a point to be noted that the energy level for the substance and the product are the same even with or without enzyme, because the only thing that changed by enzyme is the activation energy, which is this area. The substrate level towards the peak is the activation energy. Okay, so here as well, the substrate to the peak, also the activation energy, right? Energy. So you should have labeled the activation energy as well, like this one. So for the A graph, the energy level of substrate is higher than product. It shows that this reaction is to break down something. For reaction break down something, we call it catabolic reaction. And for B graph, there should be opposite way of the reaction, which they build up something, right? For building up something, the reaction is the anabolic reaction. Yeah, here I hope you get all the points here. So let us focus on catalyst today. So here is the background of catalyst. Just I've mentioned, it will dissociate hydrogen peroxide to hydrogen and oxygen gas, and it is mainly found, it can be found in pig liver, okay? And hydrogen peroxide is one of the metabolic waste and should be removed as it is toxic. So one of the reason why enzyme present in our body is to dissociate some toxic waste. Just like here, it's hydrogen peroxide, because some of our metabolic reaction happen in the body will produce hydrogen peroxide, and we need to remove it. Otherwise, we will be toxicated and we will die. So in this experiment today, we are going to investigate whether the mass of the pig liver will affect the action of the catalyst. That is the dissociation of hydrogen peroxide. So here, I want you to write an equation of the action of the enzyme and draw the energy level graph. And once more, set up the hypothesis based on the given information. Okay, so I give you some time to do it. Okay, so the equation, just write it down. And energy level, you need all the label whatever graph you're drawing. Just erase it. Here you need to draw the graph. It is a catabolic reaction and the substrates are H2O2 and the product is H2 and O2. This is the free Ng. Remember to label the Y and x-axis as well. Okay, that's the graph. So set up the hypothesis. What hypothesis have you set? Yes, the mass of the pig liver will affect the catalyst reaction. Okay, so let's move on. So here you need to state the independent variable, dependent variable, and control variable for this experiment. And let's focus on these three things first. So for independent variable, do you remember what is it? Yes, independent variable. It is the factor, it is the variable that we want to investigate here, which is something we want to investigate, which is the something that will change. For dependent variable, it will something that will change by the independent variable. That's why it's dependent. It's depend on something, right? So what is dependent in an experiment? Yes, the something we want to measure is the something we want to collect, right? For controlled variable, what is it? It's the variable to keep the same. Keep the same. So write it down here. What are the three variables here? For independent variable, something will change. For the experiment, it is the mass of liver. How about the dependent variable? There's something to be measured. What is to be measured? Yes, it's the activity of catalyst, right? And the controlled variable. Okay, just here, what will affect the enzyme activity? Can you tell me? Yes, the mass, but we will change the mass of the pig liver, the pH, and the temperature. Anything you suggested that should be kept the same here? Also, a lot of things actually. Just to suggest a point here is the source of the enzyme. because mentioned that this catalyst can be found in pig liver, but actually you cannot um, you cannot disagree that catalysts may be found in other parts of the organs also, right? So maybe for the other parts of organs founded catalysts, they maybe have different reactivity rate. So make sure that the enzyme are extracted from the same place. That is quite important here. So now we have defined the hypothesis and the independent variable, dependent variable, and the control variable here. So can you just, I'll give you a moment for you to design an experiment to think about how can the experiment carried out. By the way, you also need to think about how to measure the results. Like here, I just give you the idea that we need to measure the activity of catalysts, but what parameter will we use to get this result? This is also the thing that you need to consider when you're designing an experiment. So I'll give you some time for you to think about that. Yeah, you can just write down or draw your ideas here. Yeah. Okay, so I saw that you write something here. Okay, so let's see if your suggestions is possible after we go through all the things here. So how actually the experiment is carried out, it is stated here. The experiment is carried by setting up 3 test tubes, and each of the test tubes contain pig liver with different mass. Hold a glowing splint over the opening tube. The time needed for each glowing splint relighted is measured. So why will we use glowing splint here? Can you tell me? Yes, because oxygen will relight the glowing splint, right? And oxygen is one of the product of the dissociation. So here are the result. So after you studying the result, can you conclude the relationship of the mass of liver and the rate of reaction here? Yes, you should have noticed, figure out that the higher the mass of liver, the greater the mass of the liver, the higher the rate of reaction of the catalyst. The activity rate should be an activity rate. Okay, so the next question, and is there any factor that makes the result unreliable? If yes, how to improve it? Actually, you should realize that each of the experiments should have some loopholes in it. So these loopholes will make the results not accurate and make it be unreliable. And each time when we have carried out the experiment, there should be some discussion on it, on how to improve it, or some error that is potentially incurred here. So I will go back to this question again after we have answered the next one. Okay, so here I give you some time to think about it. So just the last part is want you to explain the result of it. So why is the conclusion here? Yeah, just greater amount of liver, just greater the activity rate of the enzyme. Why was that? Greater mass of liver means larger amount of catalyst. Yes. we write it in point form first. Larger amount of catalyst, greater mass. So what will happen if there are more catalysts here? Yeah, so it will dissociate the hydrogen peroxide more effectively, right? Dissociate H2O2 more effectively and more fast and effective, and therefore it give out that the result is a greater mass will give a higher rate of reaction, right? That should be the explanation. Okay, so any question here? No, then we get back here. Any idea of any potential areas? Just look at the experiments and the result again. Do you think that it is reliable that for the data here? It is no. Why do you think it's not reliable? You mean that there's no decimal places here? Yes, that is one of the potential error that there may be the counting error. There may be the error on data collection. Anything else? Okay, so you think that data collection is the potential error? So just look at here. How many times do you think that the result is collected? Just one time, right? So do you think that this result is representative? No. Yes. Because there's a lot of factors that will make the result wrong here. So actually every time if we do experiment, actually we will repeat the experiment 2 to 3 times and take the average result. So that is the improvements. Take several repeats the experiment for several times and take the average result. So that's it. You can go home. You can think more factors that will potentially affect the experimental result. Okay, so that's all for today's lesson. Thank you.